Hi everyone, this is Meena Sehar. I'm a senior technical marketing engineer here at Palo Alto Networks, and I'm primarily focused on AI powered ADEM. So today I want to talk to you about what AI does for you. What does AI unravel in your enterprise? How does it enable your enterprise to be successful? That's going to be our focus today. So let's look at specific use cases and targeted scenarios where we will be using AI ML techniques to troubleshoot and solve problems. Okay, so what you're looking at right now is the enterprise health dashboard. So this provides a bird's eye view of how the organization is performing, how the user experiences across the enterprise. Now, this is a global distribution of the entire workforce. What you're looking at here is the distribution of global protect connected users. We have similar tiles for branch office experience as well as a very targeted approach towards application experience monitoring. So now let's talk a bit about mobile user experience monitoring. So you can see here that the users are grouped into regional clusters, and for each cluster, you can see how many users are having a good experience and how many are having a bad experience. Now, as any network administrator would want, um, they want to know who are the users whose performance is impacted and why is their performance impacted, where is this performance impact getting introduced at, and what is my AI solution doing in order to surface these issues, in order to notify me about these issues, and also help me remediate and fix these problems. So that's what we are going to be looking at. Now, this view that you're looking at here is called network topology visualization. It's a visualization of your entire enterprise end to end, all the way from endpoint devices to the services that these users are accessing, whether it is SaaS application or it's internet traffic or private applications or critical infrastructure and networking services. Now, this view, it's not just a topology visualization, it has more information. So it's going to show exactly which areas, which segments in the service delivery chain are impacted, what kind of impact, what is the size of impact, how many users are impacted because of a particular segment. Let's say, as a network administrator, my motivation to go to the dashboard is to find out how many users are impacted and where is the impact coming from. That's going to be my number one question. So now when I look at this here, I know how many users are impacted due to home network issues, how many users are impacted due to data center or infrastructure related issues. Now, for infrastructure related issues, these need to be notified to the administrator. So incidents are proactively opened and there are notification mechanisms in place in order to alert and notify a relevant administrator. Now, let's go back to the global topology view. So right here, you're seeing another view of the segment-wise insights that we just saw, the topology visualization. So right here, when I click on the number of impacted users, this automatically opens up the segment-wise insights view, which is going to give me a breakup of the number of users and the corresponding segments which are introducing this performance impact, along with a correlation of incidents that have been opened for critical infrastructure failures. Now, when I click on a particular segment, say for example, in this case, I click on the LAN segment, I would be able to see the global distribution of users impacted specifically due to LAN performance issues. Now, where is this useful? Let us say, for example, there is a regional service provider brownout or blackout issue. Now, when I click on my service provider segment, I will be able to see this regional concentration of users. So this helps me identify if there are regional hotspots, helping me localize the problem and helping me understand where the problem lies. Now, we were looking at the global dashboard. Now, let's say I want to drill down and get down to a single user. I want to see, okay, so I see this global distribution of users impacted due to LAN performance issue. Now, where exactly is the issue? What kind of problem is happening? I want to do an impact analysis. So I click on a particular user. Now, this particular user, right from here, from this dashboard, I want to see what's happening with this user. So I hover over this user, I see some details. Now, when I click on this user, I'm shown this user's device and connectivity details. So now I know this particular user, which PA location is this user connected to, what kind of device this user is using, what kind of operating system, or the Global Protect version. Now I want to know why this user was flagged as a user impacted for performance. And this helps, and this shows the impact analysis for this particular user. So this tells me exactly for how many minutes this user's performance was impacted and which specific segments contributed to this user's performance impact. So here, this user experienced an impact for 5 minutes. And I can see here that this 5 minutes originated from the LAN segment, which also propagated to internet performance impact and Prisma Access performance impact. Now, I want to drill down further. Now, as an administrator, I want to know, is this problem persistent? Is this user having this kind of problem for a long time? Is there a pattern to this user's problem? I want to know more about this user's problem. So I can be taken quickly to the user's experience dashboard. And here I'm shown a topology view just for this user. And I can see clearly which segments are causing performance impact and why this segment has been isolated. Like, see, we saw this user had a LAN performance impact. Clearly, this user is experiencing a packet loss of 20% in his home network, which is introducing a progressive impact across the service delivery chain. Everything seems to be impacted starting from his home network. Now, I said there are some questions that I have as a network administrator. Is there a pattern to this user's behavior? Now, when I click on the LAN segment, I can see this user's historical trend data. So I can see this data all the way up to 30 days. I can understand what is the pattern in this user's home network. So why is this important? Because when a user opens a help desk ticket, as a network administrator, I need to be able to tell this user actionable insights. I can tell him, hey, it looks like your home router introduces severe latency during this peak hour, 3 to 5 p.m. every evening during weekdays. So you may want to go and look at who are the other users who are using this network, what kind of problem is happening, are they doing some bandwidth intensive work? So you may want to go talk to people who are also sharing this LAN network with you. So this is an actionable insight that we give back to the user in order to solve their problem. So the network administrator is equipped with telemetry, comprehensive telemetry for each segment, so that a user already has for a user's problem, the network administrator already has insights, both from past and also proactive insights. And we are also able to tell the user exactly how they should remediate their problem. Now, we talked about how we can drill down from the global enterprise view, what insights we can get from the enterprise view, and how we are able to drill down to a single user's problem. Now, let's talk a bit more about how we can surface and troubleshoot a specific user's problem. What other insights can we share with our end users? So, like I mentioned earlier, we have the topology view, which shares a lot of useful insights for network administrators to share with the end users. As an example, I've highlighted here, this user is having wireless issues. So clearly, this user is having some signal quality issues. His signal strength is only 50%, and his TXRX bandwidth is also quite low, which is why AI powered ADEM has already isolated this segment as a potentially performance impacting segment. Now, when this user opens a help desk ticket saying there is a performance issue in accessing applications, the administrator already has this information along with historical data to share the insight with the user. And not just the topographical view, not just the historical trends, we also have per hop insights, both through the underlay network and the overlay network. So we are able to tell precisely which hop, even inside the service provider network, is introducing latency, loss, or jitter and is affecting the performance for an end user or a branch office. Now, we talked about how an administrator can share insights with users. Now, with all of this rich telemetry that we collect, what if we notify the users directly? What is the benefit in that? So this means that the user does not even have to open a help desk ticket. We are able to proactively alert and notify a user even before the performance impacting scenario aggravates and causes real perceivable user impact. So this is called self-serve, where we are able to notify a user directly on their endpoint devices, and we tell them, hey, user, your CPU is going way beyond tolerable limits. A persistent CPU spike like this will cause performance impact. Look at the top processes that are causing this CPU spike, or memory utilization is spiking up. These are the top processes that are consuming memory. Or say in this example that you're looking at here, the user is experiencing poor Wi-Fi connection, and we are able to say that, hey user, you were previously connected to a very good network which offered you good signal strength, good TXRX bandwidth. The network that you're currently connected to is likely to impact your performance because of the poor signal strength or poor TXRX bandwidth that's available for you. So why don't you switch back to the previous network that you were connected to? So we are able to offer guided recommendations in very simple, easy to consume format for all users in an enterprise. So that way, users are able to use this information to fix the issues that are within their control automatically. Now let's talk a bit about performance monitoring for branch offices. So far we were looking at how we can monitor user experience across the organization, user experience for a single user, and how we can notify a single user. So similarly, what can we do for branch offices performance monitoring? With AI-powered ADEM, we offer multi-WAN path visibility. So if you look at a Prisma SD-WAN branch, today we support multiple WAN paths, like for example, direct internet or Prisma Access standard VPN path, or the secure fabric Prisma SD-WAN VPN path, which connects to a Prisma SD-WAN data center. So irrespective of the path policy that is configured, we are able to monitor all of the paths for that particular application. And we are able to provide telemetry and visibility for application performance across all of these paths. And all of this requires absolutely no configuration. So all of this configuration is automatically taken from Prisma SD-WAN and AI-powered ADEM integration. And the paths are automatically detected from the path policy configuration. So other than the applications that need to be monitored, there is no configuration that is required in order to enable this visibility for Prisma SD-WAN branch offices. Now, for non-Prisma SD-WAN sites, with AI-powered ADEM, we are also able to offer performance monitoring. We are able to detect if there is a latency in round trip time on the VPN paths. So we are also able to provide at an organization level how a particular branch site is performing, whether it is a Prisma SD-WAN branch site or a non-Prisma SD-WAN site, other third-party vendor SD-WAN sites. We are able to offer that visibility. Now, let's look at application troubleshooting. So let's say, for example, there is a performance issue with Zoom. How do we troubleshoot this problem? So today with AI-powered ADEM, we have Zoom integration, which allows us to consume Zoom QSS data and correlate it with the performance telemetry that we have collected from ADEM and provide the root cause. Now, let us say, for example, users are on a Zoom call And a couple of users are experiencing some kind of performance impact, like they drop out of the call, their audio is jittery, their screen share freezes, issues like that, which we normally face on a day-to-day basis. Now, if this issue is recurrent, the user is likely going to open a help desk ticket. Now, a Zoom administrator or a help desk engineer, how do they troubleshoot this problem? So, if a user says, hey, my screen share keeps freezing every time I share, how do they troubleshoot this problem? First of all, historical data is required. Second, there are multiple elements that could cause that performance impact. Now, thankfully, with AI powered ADEM, we do this multi domain analysis. We are able to we have proactive visibility into the performance of several segments that impact the performance of a user. And we are also able to consume the Zoom telemetry directly from the Zoom application itself, which we get through API. So this data that we get from Zoom gives us precisely what is the latency, loss, jitter that is experienced by a user at a per meeting level for audio, video, and screen share. Now we take this data and we correlate it with the ADEM performance insights that we have, and we are able to tell exactly this user's screen share is freezing because this user's home network is introducing 20% packet loss. So we are able to make that correlation with the insights that we collect um, with the Zoom telemetry, and we are able to provide the exact root cause. So what I'm showing you here is the calendar view for Zoom meetings. So this is a user's experience dashboard. On this user's dashboard, as an administrator, I am able to go into this user's dashboard and select the particular meeting which the user has complained about. Let's say, and the color legend that you have to remember throughout this presentation is red indicates bad performance, amber is fair performance, and green was good performance, healthy. So all of these meetings this user took on February 4, 2024, the green ones are all good, no issues. The user has raised a problem with this particular meeting ID, which is highlighted in red already. So we know, yes, this user had a problem. Now, when I click on this meeting ID, I would be able to see exactly the audio video screen share impacted minutes and also the correlation as to why this user's performance was impacted. So this helps me give back to the user actionable insights as to why they were seeing a problem and help them remediate the problem. Now let's look at how we can troubleshoot infrastructure issues. So far, we looked at user experience issues, branch experience issues, application experience issues. Now, what can we do about infrastructure issues? So we saw this segment-wise insights on the SASE Health dashboard. And right here, the first few segments are within the user's control. The user's endpoint device, user's wireless network, LAN, or the service provider. Now, anything beyond the service provider is beyond the user's control. From Prisma Access infrastructure, data center services, network services, or applications, we raise incidents in order to notify administrators to fix these infrastructure issues and also tell them why these issues are happening, provide them telemetry in order to identify or isolate the exact root cause that is causing the problem, and also guided remediation for network administrators to fix these problems. So what you're looking at here is an incident that has been raised for a service connection down issue. So here in the incident, you can see the number of impacted users. So we are able to detect how many users are potentially impacted because of this infrastructure performance issue. And this allows the administrators to understand what is the size of impact. How many users who are currently using this service connection link to access private applications are impacted. So these many number of users are impacted for this time range. Now, I want to know now with this incident, I know that an issue has happened. I want to know why this issue happened. So we show granular telemetry, and we show what is the baseline, what is expected on this service connection, what is the normal behavior on this service connection, and did we see an anomaly. So we can see here, whatever you see with the light blue shadow, that's the baseline, and the solid blue line indicates the current value recorded. Anything that is shown in amber is a deviation, an anomaly that happened. So here I can see that the number of users on this particular service connection, there was an increase in the number of users. This is detected as an anomaly. Now, this is an important insight for an administrator, because likely because of the number of users who are accessing this private application, who are going through this service connection, has scaled up, causing the service connection, causing a performance impact in the service connection. There's likely latency and congestion that is introduced in this VPN path. So this is probably a cue for the administrator to take some effort in order to streamline this user activity by either raising requests to scale up the service connection nodes, or take the necessary action that is needed. So this anomaly deviation clearly indicates what is normal for the enterprise and what is not normal, and what is the action that must be taken by the administrator. And also, when an incident is raised, we also want to make sure there is no alert fatigue. All related incidents should automatically be correlated, and the child incidents are automatically associated with the parent incident. And the administrator can focus only on the main incident which is causing the problem, which is basically the service connection is down, and all other child incidents like BGP neighborship down are automatically associated as child events to this parent event. And what you're looking at here is the remediation playbook. So this has guided remediation steps in order to fix the problem. And we also have several notification mechanisms available, and a whole bunch of incident management mechanisms that are available in order to manage an incident, and also for the network administrator to be notified of an incident. In this case here, we have webhook integration. So you can see this incident has already been updated in the webhook endpoint that has been configured by the administrator. We also have native ServiceNow integration that is available, which takes in bi-directional inputs. So as soon as an incident is generated, a ticket is raised on ServiceNow, and when the incident is cleared, the ticket is also updated on ServiceNow. We also have email notification mechanisms available, and all of this is configured as part of the incident. So we talked about infrastructure incidents. Now, let's talk about how we can make things easy for an administrator to query certain posture queries or certain application access queries very specific to users. How do we make querying easy? What kind of conversational tools that we have and built in the product today in order to facilitate easy troubleshooting for administrators? So I want to introduce the Access Analyzer, which is a natural language query interface that is built into the product today, where administrators can easily type in a query and find out a bunch of information. So I'm going to talk about certain specific use cases that we can address using the Access Analyzer. The first one that we are looking at here is a query that the administrator can type in to find out how many users are not meeting best practice security best practice requirements, or are failing posture checks. Let's say, for example, I have configured a hip check profile called medium risk device or high risk device in order to find out how many users have turned off their AV, or how many users have turned off their firewall. And this is important for me to know in order to enforce my enterprise's security best practices. Now, when I run this query, I get a list of users who have failed the hip check. So in the back end, what we are basically doing is we are trying to find out who are all the users who are matching this HIP profile, which checks for a certain best practice departure, a certain posture departure, like turning off firewall or turning off AV. Now I get the list of users. I can download this list of users, and I can use my MDM mechanism or whatever mechanism I have in order to push notifications to users in my enterprise in order to alert them or coach them to re-enable or make sure that they're compliant with the security posture or the security best practices. So this allows an administrator to easily monitor or feel the pulse of an enterprise when it comes to enforcing security best practices. Now, I want to show another example for Act Access Analyzer query. So let's take this query here. A particular user raises a help desk ticket that she is not able to access a certain application. So I type in the query, can mobile user, this particular user, access the application from a specific device? Now, when I run this query, what happens in the backend with the access analyzer is it does multi-domain analysis. Now, as an administrator, many of you here are administrators. So if a user opens a help desk ticket saying, I can't access this application, how many number of permutations and combinations can you think of? There are so many reasons why a user's application access gets blocked. Now, for a single administrator, a single engineer to go through all of this multi-domain analysis, to go through all of these areas to investigate and find out why this user's access is blocked, it takes a lot of man hours and it takes a lot of people as well, because not all engineers have access to the same resources. Like, for example, the user would have to go talk to a security administrator for security policy access. So there are several domains that need to be checked. And with the access analyzer query, we are simply able to do this query within a minute and identify why this user's access is not available. In this example that I'm showing you here, this query access analyzer has easily identified that this user is denied access because of a security policy rule. And the security policy rule is denying access to this user because this rule specifically blocks users who are failing a posture check. So in this case, corporate AV check is failed for this user. This user has likely turned off AV and hence is blocked access to corporate resources. And that's why this user is not able to access. So many times users inadvertently do certain things which compromise the user's security infrastructure as well as the enterprise's security infrastructure because of lateral movement of malware. So it is very important for enterprises to enforce these security best practices, catch users who are failing security best practices, and enforce policies which deny them further access to corporate resources. And an inadvertent user may not be aware of all of this. So when this user opens a help desk ticket, the access analyzer is able to do this multi-domain analysis and pinpoint exactly why this user's access is blocked. And all with a natural language query interface. So, and that brings us to the end of the use cases specifically that we are targeting with AI-powered ADEM.